Hey there, welcome back to the channel. Let's just get right into it. So in the previous video, we covered like coalescing the right and the left block. So what does that mean? So when we get a pointer to our when our myFree function gets a pointer, like this blocks need to be free, we check its adjacent blocks, like the right one and the left one, to check if both of them are free. If both of them are free, then obviously the a better way to reduce external fragmentation is like to merge all three of them and make a bigger free block and then add it to the start of the free list. So that's what we did. That's what coalescing RL function does. But not always we will have both of the blocks free, right? There'll be a time when, let's say, only the left block is free. So let's start covering that, you know? So let's just get right into it. So let's make it coalescing L. Yeah. So free pointer, we send it a pointer, cool. Coalescing, yep, this is fine. So let's make another function which is void coalescing. What is it? L. Yeah, it gets a void pointer to pointer free pointer, and it gets what was it? Pointer, right? What have I called that? Yeah. Okay. So yeah, let's just get right into it. So this code is same. So let's just paste it, paste the total new size. And the total new size will depend like the total new size. So let me just um, should I show it to you guys? Okay, you guys. Okay, I'll show it to you guys. So let's say I have a whiteboard. I'll explain it to you. So uh, let's say this is my block. This is the block which I got the pointer to. So this is what well, not this, but yeah, this is the allocated block. We got a pointer to this allocated block. Why is this allocated block? Because it just has a size value at the header and a size value at the footer. So yeah, this is what allocated block looks like. Just to give you a demo, this is what a free block looks like. It has a size value. It also has a footer size value, same, but it has two additional things, which is the next pointer and a previous pointer. Why are these present? Because this is a free block, and free block should be present inside a doubly linked free list. It's a doubly linked list. So next pointer will point to the next free block. So our algorithm initially is like a first spin algorithm. So every free block is present inside the free list, so as to not call SBRK again and again, to not make that syscall. So let's say there's adjacent free block like here adjacent to it, and it looks like this. Cool. It has the size pointer size. So the total size that it will have will look like this. This, and this, where it will have the same thing size. The total size that it will have has been reduced. So this is, let's say this is x and this is y. So the total size will be x plus y plus s plus s. So that's what we have to change. So yeah, let's just get into it. So our total size will be block size, which is the size of our block that we got the pointer to, which needs to be freed, like which needs to be merged, you can say. So block size plus left size. We don't have right size in this, and we will be adding two size values, and there are no pointer sizes because We don't have the right block. Sorry. So this is the total new size. That's fine. Let's get a point. So this is the same thing. Yeah, pointer to the left block will look like pointer minus two sizes minus left size minus two pointer size. Boom, boom, and I'm at the left block now. Okay, cool. And the right block. Yeah, I don't need this. So this is fine. So now I will use the function which I wrote in the previous video, which is skip block. So what skip block does is that we give it a pointer to the we give it a pointer to the block, not necessarily the pointer, the position of where the next pointer of the free block lies, and we give it to the function, and then we give it free pointer. Now what this basically does is this should be wait, we are already getting it by address, right? Why are we skip block is pointer? Yeah, this should not be this. Yeah, it's yeah, cool. Don't know why did we did that, but okay, cool. Okay, so yeah, we over here. We skip the what this does is it will change the previous and next values of like many different things. So it will let's say it was somewhere in the free list, like the left block somewhere in the free list, uh, and now it will be. Well, now I have the function there. 7 minutes in and I'm not even explaining things. So okay, nobody really watches my videos till this point, but if you're watching this, hey, thanks for watching. So I will explain for you. So what skip block does is it gets a pointer. It does not get a pointer at the start of the block. It gets at the a specific position. Just consider that. And what it does is that let's say there's a previous block, like inside the free list, that block is present. Previous block, this block, and the next block. So now the previous block, like this block should not point to this because we are removing this. We will be adding this block in the start of the free list, right? So this should not point to this. It will skip this and point to this, and this block's previous pointer should not point to this. It should directly point to this one. So that's what this logic does. I haven't tested it, but I will do it once this coalescing L and R and uh, the other thing is completed. So yeah, okay. So now to change the header and these things, right? Header and footer values. Yeah, okay. So header, this is fine. Yeah, so the header will look like left block, so left block pointer. Yeah, minus size resize. This is fine. Yeah, so I get header, and then for the footer, I can do so size t pointer, get pointer. Let's say I was a pointer. So now pointer plus um, our original block size. That's what we did over here, right? Okay. So our original block size, and I guess it's done. Yep, that's it. And then we change the values. So header should now have the value total new size, and footer should have the value total new size. Ooh, cool. So now the logic is just a minute, give me a minute. Just Yeah, hey there, I'm back. So, I feel like uh, the, in the previous videos, I used to uh, not understand anything of what I'm going to write, and now I'm just like flowing. I know stuff. I know how to move the pointers and all. I still don't know a lot of stuff. I still get stuck on a lot of things, but this is cool. Wait, what did I do for the right size? Block size is fine. Wait, block size is fine. Pointer minus. Yeah, this is fine. And then for this is fine. Yeah, okay. Yeah, this is fine. No, 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 it's correct. I thought I was wrong. Yeah, okay. So I get the right size, and then, oh, sorry. So size T, total new size should now look like block size plus right size. Yeah. So let me show you the thing again. Yeah. So this coalescing was in the case of when we are merging like this is our main block. This was our main block, and we were merging the left one. For you guys, this must be left one. Yeah. So now, let's say I want to merge the right one. So this is what it will look like. Should I erase this? Yeah. Let's erase this. And this is fine. I'm really right. No problemo. So let's say I want to merge the right block instead, like left block is allocated or something else. So this is what it looks like. Boom, this is S, this is P, this is P, this is S. So what will be the allocated size now? Well, it will be X. Oh, this is X. So X plus Y, duh, and it won't like we will conserve this P, but it won't need these two sizes, right? So it's basically the same thing, right? Yeah, it's basically the same thing. The two pointers, even though they are present there, we can just visualize that they are present over on this side. So yeah. Also, now that I like think about it, hmm, sorry. Okay, wait, let me close up some stuff that I have open. Yeah, okay. Oh, it's this. Yeah, I forgot the hotkeys. So okay. So now I understand one thing. Like I'm coalescing this, and like I'm skipping this. This is fine, but I'm not changing like the values of like I'm not doing any. No, I guess coalescing skipping is doing that, but I should create spaces over here, right? So block is created. So what coalescing R does is that let's say skip block, right free block, left free block. This is fine. So we go to coalescing RL. We get a point to the left block and right block. We change its values, but we don't change like what it's pointing to. So you're getting me? Yeah, we can rather make it so like we are returning a void pointer to it, right? Sorry. So coalescing, let's say R. Okay, that's cool. And then we will get a value over here. Let's say void pointer new block, right? And we'll say new block is equal to this, or new block is equal to this. Yeah, why I'm doing this, you'll understand it afterwards, but okay. So void pointer, void pointer, void pointer, this is fine. Yeah, okay. So total size is the same thing. We just eat up the two size t values, block size plus right size, yeah, and get a pointer to the right block. So void pointer right block is equal to just copy this thing, yeah, which is pointer plus block size plus size t size. It pointer block size, yeah, yeah, it's perfect. Thanks previous me, because now I have to like don't write anything. Yeah, now change the values. So size the header is equal to, let's just get from over here. Yeah, let's make it ourselves. So size t pointer this should be char pointer. The header should be the same thing. So size t header is like the pointer itself. Well, pointer minus you can say pointer minus size t size. Yeah, pointer minus size t size. Yeah, perfect. And for the footer, it is char pointer plus two size t sizes, size t sizes plus two pointer sizes, or we could have like used right block, right? Like, duh. So right block plus two pointer sizes plus right block. Yeah. Plus it's still two pointer sizes plus right size, and we are the that pointer. Yeah. Okay. And then we change the header and footer. Yeah. Okay. So this is fine. So now, why did I do this? So let's say we get a pointer. Let me first write this. So right block, new block is equal to coalescing, right, three pointer, passing pointer, and else condition when both of them are false. So there is no adjacent free block. So in that case, we just um, well, not necessarily this. So we are at that pointer stage. So now we have to create pointer ourselves. So now we have to make it so like the um, Yeah, okay. So void pointer, let's say next pointer of current block. Yeah, next point of the current block is this one itself, which is pointer, or should I say like new block. Hmm. It can stay the same. By default, it is pointer, as I said. So new block by default it is pointer. If it gets overlap, we are not sure. It's okay. So we get over here, the current block size, and then previous pointer of current block is void pointer to pointer, char pointer, new block, and then we move it ahead by pointer size. Yeah, okay. So now I have to like change the values of it. So now pointer size has this. So free pointer has this now. So free pointer should now point to this. So my free was called. Then I get free pointer. Yeah, okay. So let me just check the one of the things over here. Yeah. Yeah, so split block needs to point to this. So split block the next pointer of the split block to the pointer of the split block. Let's exercise this is fine. If free pointer now. The split block should be free pointer now and free pointer should be split block. Yeah. Okay. Cool. So over here. So next, sorry, yeah, next pointer, sorry, next pointer of the current block should definitely point to three pointer now, and then three pointer should now be next pointer of the current block. So what we did over here is that we said that the pointer, like the new block was created, it has a next and a free pointer, right? So we say when we are adding the new block to the inside the free list in the first place, like at the first position, then free pointer that was pointing to the next block, it should now point to the new block, right? So that's what we did. We said that the next pointer of the current block should instead point to the other should instead point to the old block, and then free pointer will now point to the new block. So that's what we did. So here the addition is done, and now the previous block thing is remaining. So I get a pointer to this, right? We have a pointer to the previous block. Yeah, let's first see like so previous pointer of the current block should be null because it's the first block, right? It should point to null. Like the first block's previous pointer, there's nothing previous to that. It is the first block, so it should point to null, and well, its value should be um the I have to get the I have to get to the next block. Yeah, sorry. So the next block is equal to what do we say the next block is the void pointer next block is equal to let's say the current block's next pointer. Yeah. So what was it? So this is the current block, right? Yeah, this is what we want. So dereferenced next pointer of the current block. So dereference next pointer of the current block. If next block is not equal to null, dereference next block. Yeah. Sorry. So if next block is not equal to null, then we will change previous pointer to it. So previous pointer of the next block. So void pointer, previous pointer of the next block should be equal to, so we have the next block, right? And we don't necessarily want um, this. We can just cast it into, yeah. Void pointer to pointer next block is casting into void pointer to pointer, char pointer, the next block. And the next block you're pointing to is to this. So this is where it points to. And then we move it ahead by pointer size. Yeah. So we move it ahead by pointer size, and then to change this value. So previous pointer of the next block should now have the value inside it. What should be the value? That should be the address of the uh, current new block. That should be new block instead. Next point of the current block. Yeah, to make it look like cool or something else. Whatever. This is the pointer to pointer. Yeah, we are just treat it like that. That's fine. So yeah. Okay, so this is done, I guess. I hope this is done. So my free function. So our work is done over here. Let's try. So make a lot of things that aren't working. Footer size, it wasn't used. Unknown type. Well, oh yeah, I know this. I know this, I know this. So apparently, I was not aware of this, but bool values are not like default. Wait, how many errors? Yeah. 3 warnings, 16 errors, boom. 4 warnings, 1 error. That's it. Boom, 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 boom. So else if right block, so use of undeclared identifier right block, it should be else if, yeah, it should be right free. Yep, it worked. What are the warnings? So current block size wasn't used, and then non-void function does not return a value. 4014 with footer size. Let me fix the unused things. So current block size and footer size wasn't used. And 146. So that is 46. Yeah, this is fine. If it wasn't used, this is fine. And then current block size at 444. Yeah, this is fine too. So 401 normal function does not return a value. W return type. Okay. So 401 So one. Oh, okay, okay, okay. Yeah, yeah, yeah. It should indeed return a value which is uh, it should return a value of, well, the left block that we got. Well, for R, in the case of RL, we should return a value. Sorry, let me think about it. So I guess you can call like void pointer new pointer is equal to, well, since we are merging R and L, so left blocks pointer, that's what we should return, which is pointer minus two sizes, left size, two pointer sizes. Yep, left block is what we should return. Yeah, okay, left block. Yeah, just keeping it modular. I know we are just declaring stuff, but yeah, I just like it when it's readable, if you can see. Duh. So void pointer, new pointer. In the case of L, is the same thing. We just take the left block, right? It's the same thing in the case of L. And in the case of R, then pointer. In the case of R, it's a bit different. So void pointer, new pointer is actually the pointer that we got. So we'll just return new pointer. So this should work. Yep. And let's say I hope it works, but I know it's not going to. But let's try. So make and n driver. This is the executable that will test um, how deep are we. Well, I'm not testing stuff, so debug code. So oh, sorry, GC boom boom. So if segmentation fault, why did we get a segmentation fault? Well, we'll just start adding print statements. How many minutes in? 33 minutes in. Okay, so traverse fearless. So let's say printf block of size, actual size, found, block found with this capital F, actual size. So we'll say whenever we are traversing like the free list, we'll see a thing which will tell us like we should all add another statement which is like looking for a block, right? Over here we'll add this. So printf looking for a block of size percentage value requested size. So this is fine. So looking for block of size 2040, 2040, 48 block found of 2056. Let's get inside the free function, right? looking to free a block of size percentage value, boom, 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 boom. Okay, looking for a block of size 48, looking to free a block of 2049 by 49. Oh, I messed up. Yup, I know like I know what happened. I know what happened. Damn, damn. How cool is that? That I know what has happened. Like I figure out something. Like I don't know if it just definitely that error is totally unrelated to what I'm talking about, but I know what that is. So sorry. So what one change that I've done is like to to show that it's a allocated block. What we do over here is that, as you can see, we check if it's an odd number. So what that means is that if it's an odd number, then we can say it's allocated block. But when we are making like total new size, we want it to be like cool. We don't want anything related to like this thing. Yeah, so block size is this. This is the current block size that is actually allocated, which needs to be freed. And I will minus one this, so it's allocated. And then left side should also be minus one. And this should also be minus one. Yeah, so we get the correct sizes for each of them. Uh, the extra 1 byte is not in the you can say the space is not extra 1 byte. It's just sorry, it's just something to denote it by. So now this is fine. Here the same thing because our current block is allocated and the left one is free. Well, the left one is free. Why are we doing this? Yeah, okay. Duh. Only the current block is allocated. Only the current block is allocated. Yeah, okay. So if I do this, looking for a block of 2040, looking for a block of 2040, looking to free a block of size 2049. Why is that? Let's look at the traces. So, and then short traces, the 0th one, yeah. So 2040, we write. Free one, what free one means? 2040. We are looking to free a block of 2049. Why are we looking to free a block of 2049? Why are we looking to free a block of 2049? Yeah, current block size is minus one. Yeah, it's just for showing purposes. Even though, yeah, I guess this is working correctly as I would expect. Why, like, so this is the 0th thing. So 2040, this is this one, the 0th allocation, and then the one first allocation is 2040. This is this one, and now you will see when we are trying to free the first allocation over here. Why are we getting 2048? Well, that's because it should be for 2056 actually. Why are we just getting 48? Hmm. It should be 456 actually. So when we call my malloc and we don't find anything, so here we go. We call so okay the printf no appropriate block found in free list calling SBRK. Yeah, okay. And then we say new block of size line size plus basically this the whole thing. Yeah, even though we call it, the new block size is actually this size this, two size t values and a pointer size. Why an extra pointer size? For additional pointer sizes to accommodate the previous pointer. Yeah, I know this will haunt me. I knew that this will haunt me. Like okay, in the next video we'll make this change. Yeah, in the next video we'll make this change once and for all. For now, I guess this is right. So 2048. So we're saying like the smallest allocation, let's say 0. We're still calling this. This should be, yep, an additional pointer size, actually. And here it should be pointer size. I know it's going to haunt me. I'm not going to keep this change, but for now, I'm just for my convenience. The new block, no prepared blocks found of this, new block of that size. Yeah, this is this. Yeah, 2056, this is fine. Looking for a block to free 2056. Uh, yeah, there's a block of size 2057. Looking for a block of size 2040. Not prepared block, calling this Miyaki. Size 2057. Looking for a block of size 2056. And then segmentation font. Boom. Where is this? I guess this is enough for today. Like, okay, 44 minutes video. This is fine. We'll debug the rest of the thing that we messed up. Like, we'll fix our past later on. It's fine for today. Lot of work. So you can diff, you have to keep the stable. I will do. I will remove the footer size. I should remove all the print statements, and then the coalescing thing is fine. Yeah, just basically allocator.c. I have to remove all the print statements that I added. Block of size this. This is complete. This is fine. And this is fine. And the deeper code. So now it should look like okay. So let's remove this change that we added in the range of 248. Okay. So and then 248. Yeah, pointer size one. Yeah, pointer size, void pointer, block size, yeah, -1 is fine. Yeah, this is fine again. This should be okay. So void pointer, new pointer, this is fine, this is fine, this is fine. -1, new pointer. Yeah, okay. It's good to go. So get status, clean it. Wait, what branch are they in? Yeah, they are in free. That's fine. So let's push it. So get, yeah, that's the correct one. So get add, get commit dash and um coalescing logic complete. What was the previous thing? Yeah, coalescing right end of coalescing complete. So get, yeah, so the coalescing logic is complete. And then git push origin free, right? This should work, right? The pull request for free and then this. So free to free, new branch was created. Boom, 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 boom. Yeah, let's go. So that is it for today. Uh, I guess that is it. So I'm Aditya Bacharni and I'm an engineer for fun. Bye.